Okay, so before beginning the even ones, we're going to explain the even ones on this video. Let's go back and review what we learned on Friday. That's saying that any root, doesn't matter if it's a square root, cube root, fourth root, fifth root, of anything to any power, that radical could be rewritten as a rational exponent. What is a rational exponent? Well, your b is right there, and a rational number is a fraction. So when we say rational exponent, we're talking about an exponent that's actually a fraction. So up here in the exponent position, we're going to have a fraction, and the numerator of that rational exponent is p, and the denominator of that rational exponent is r. So we need to have this memorized. We need to understand this, right? That the root, any root of any item to whatever power, you could rewrite it as that same item to the rational exponent power over root. Okay. Not only that, the p doesn't even have to be inside the radical. I could have also written it like this, where I have the p on the outside, and I have the whatever root of whatever term. So it doesn't matter if the p, the power, is on the outside of the parentheses or even on the inside of the radical itself. That p is going to always be the numerator of your rational exponent. And the r, the root, is always going to be the denominator of the rational exponent. Do we understand that?
Yeah.
I hope so. If you don't understand that, you're going to, forget it. You're going to mess up on this whole entire section. So let's jump back to explaining the even ones on this one. There's already a video explaining the odd ones, so here's the even ones. And just like any square root problem, we could split the square root. As long as there's no addition or subtraction going on in here, it's all multiplication, you're able to split that square root. So we really have the fifth root of 243 and the fifth root of x to the 10th, okay? Now, the Casio itself will do this for you, right? The fifth root of 243. You even could do it on the Texas Instrument. Okay, so the calculator says that this answer is 3, okay? And now on this guy over here, this is where we're going to apply this power over root, all right? So it's going to be x with the power 10 divided by the root 5. And 10 divided by 5 is 2. So in reality, this just simplifies down to x squared. So there's your answer, 3x squared. Pretty easy, huh? Okay. Let's move on to number 12. All right, guys, listen up. So with the Casio, or actually with any calculator, you got to look for the root symbol. So if you're looking for the root symbol on the Casio, you can see that right here we have the third root. Right here we have a square root symbol with the square, with the block, with empty spaces, both on the root and on whatever's inside the root. So in order to get to this, you're going to have to hit the second button, shift button. This button up here, shift. It's that color. It'll take you there. And when you click that, you'll be able to see an empty spot right here where you put the 5 for the fifth root and the 243. Hit equal. It'll give you the answer 3. Now, of course, this will not work when you have variables in there, so you need to still know how to do this. Let's say you had a different calculator, like this one, the TI, Texas Instrument. This one's a little weirder. When you look for the square root, it's right there. And you're going to have to hit the second button or the shift button to get to the square root. But since it's a different root other than square, you're going to have to use this one, which has an X in the root position. And the screen doesn't nicely put it. So when you want the fifth root, you're going to have to hit the number 5. And then you hit second and that X root button, which is this, and it'll actually show the X root. So you type in the 5 first, that represents that it's the fifth root. Then you type in 243, hit equal, your answer will be 3. So I hope that kind of helps you guys out with the calculators. Let's jump to number 12. On number 12, this is a square root, which means you cannot have a negative in there, right? Whenever you have a square root of a negative, that ends up being an I, imaginary. So what you could do is just take this minus sign, move it out. It'll be an I on the outside. And what do you have left? You have the square root of 14a in parentheses squared. Now, if you wanted to show your work, you could rewrite this as 14a to the power of a rational exponent, a fraction that'll be the power over the root. So that'd be 2 over 2. Remember, a square root, when there's no root in here, that automatically you assume that it's 2. So it'd be 2 over 2. So you'd have a 2 divided by 2 with an I out here in front, which means that you have I times 14a, because the 2 over 2 is really a 1, and 14a to the 1 is just 14a, which the real answer would be, or not the real answer, I shouldn't say real, it's imaginary. The final answer would be 14ai at the very end. But on your answer sheet on the back side, they don't even put this specific answer. They just say that it's not real. They just say not real. Okay? So that's number 12. 14, any radical you could split, especially if there's no addition or subtraction on the inside. So what we really have is the square root of 16m squared over the square root of 25. It's like two separate problems. This one's really easy. The square root of 25 is 5. And up on top, let me do this square root of 16m squared right here separately. And I'm going to separate the root to the 16 and to the m squared. The square root of 16 is 4, and the square root of m squared is m. So your final answer is 4m divided by 5. Let's jump to number 16. Okay, again, the key point or key concept of this lesson is to understand that whatever root you have, if it has a power in here, you could rewrite it as a rational exponent. So let's rewrite this as a rational exponent. You have 2x in the parenthesis, and let's write a fraction as an exponent up here, and that fraction has the power as the numerator over the root as the denominator. So that will be 8 over 2, and 8 divided by 2 is 4. So what you really have is 2x in parentheses to the 4th power. Now that really means 2x times 2x times 2x times 2x. Or you could distribute, and you'll have 2 to the 4th, which is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So you have 16x to the 4th as your final answer on number 16. Let's jump to number 18. Again, whenever you have multiplication on the inside, you could just split up that root. Let's do that. Let's split that third root to the 216 to the p to the third and the q to the 9th. So on the calculator, you could do the third root of 216. 6. Okay, so the answer is 6 on the calculator. Thank you for that. Now right here, you could show your work, or you could logically say the third root of something to the third power, the third root and the third power, they undo themselves. That would just be p. Okay? Or you could also say, well, I already know that the root will be the denominator of my rational exponent. The power will be the numerator of my rational exponent. So I'll really have p to the 3 divided by 3. 3 divided by 3 is 1, so it's p to the 1. Either way, you should just get p for this. Over here, let's use that logic of power over root. 9 over 3 is 9 divided by 3. So you really have q to the third power. 9 divided by 3 is 3. So I'm not showing my work here, I apologize, but I hope we understand, and we see, and we are able to conclude that the power always goes over the root as a rational exponent. Now in all these problems, it works out beautifully where, oh, 9 is divisible by 3. There will be some questions in the future that don't work out that nicely. Let's jump to number 20. Same deal. We are going to split that third root to each of those 3 terms. So some of us might be thinking, wait a minute, you can't do the square root of a negative. Well, yeah, we're not doing the square root, we're doing the third root. And you could actually do it on the calculator. You'll see that the answer is -3, right? Or you could even think about it, say what number times itself? 3 times gives you a -27. That'd be -3 times a -3. It's +9 times another -3. That'll get you that -27. And right here we do have an x that we're going to place next. And it does work out beautifully because power over root 9 divided by 3 is 3. And last but not least, y to the power over root 12 divided by 3 is 4. And there you go, -3x to the third, y to the 4th. Moving on to the next, even number 22. Splitting up that root, that 5th root that is. So let's put the 5th root on -32. Whoops. let's put the fifth root on x to the fifth, and let's put the fifth root on y to the 10th. So all we did was split up that fifth root to each of the terms on the inside of the radical. And what number times itself 5 times will give you a negative 32, or you could do it on the calculator, negative 2, that's right. Calculator will just give you that nice answer, negative 2. And then the fifth root of x to the fifth, that undoes itself, so it's just x. And the last one, let's actually think power over root. We have y, power of 10 divided by the root 5, it's going to be y to the second. So I hope you guys understand, I'm not showing my work. I mean, I could be showing my work. I should be probably going y to the 10 divided by 5, and then from there you get the y to the second. But as long as you know what I'm doing and you could get that answer, we are good. Moving on to number 24. Ridiculously easy. I mean, you don't even have to change it to a rational exponent. You could, and you get 3/3. But the bottom line is that third root will undo with the third power. So your final answer is just the binomial 2x plus 1. And you don't even need the parentheses, just 2x plus 1, and that's it. Number 26. So right here, yeah, we need that skill of rewriting our radical as a rational exponent. So our base in this case is x minus 5. And then we're going to put the power 8 divided by the root 4. So we're going to put 8 divided by 4, and that is 2. So what we really have here is x minus 5 to the second power. However, whenever you could simplify anything, they usually do simplify it. So x minus 5 in parentheses to the second power, that should be technically x minus 5 times x minus 5, where you would distribute x times x is x squared, x times negative 5 is negative 5x. Negative 5 times x is another negative 5x, and negative 5 times negative 5 is positive 25. Those middle terms could be combined. So your final answer for number 26, I believe on the back, should be x squared minus 10x plus 25.
For 26?
For 26. So on the answers, it actually says x minus 5 in parentheses to the second. Okay. All right. So yeah, this is the answer. Well, we already knew that, right? But let's say final exam, multiple choice, you don't see this answer, they're probably going to write it as a quadratic trinomial. Not only that, this is a good way to lead up to the next question, because this next question, you have a quadratic trinomial. There's pluses between it, which means you cannot split up the root. You can't put the square root on the x squared, squared on the 10. Can't do that. Only when you have multiplication. And since we have addition, you're stuck. Unless you have the skills from semester 1 where you recognize that this is a quadratic trinomial where the a value is 1. And whenever you have a quadratic trinomial where the a value is 1, you could factor by putting an x there and x there, or you could try to factor by putting an x there and there, and think what times what is my c value that if I combine together is my b value? 5, right? So you'd really have an x plus 5 times an x plus 5. So why would I want to factor that? Because now, since it's the identical binomial, I could write that binomial inside parentheses squared. So x plus 5 squared. So do we understand how this quadratic trinomial became these guys, which became this guy? Okay, and of course we do have the square root over that whole thing. And then right there, the square root and the square eliminate themselves. Or you could write it as a rational exponent, and you'll have the binomial x plus 5 to the power of 2 over 2, which is really just x plus 5 to the 1, which is really just x plus 5. Either way, your answer is x plus 5. So I want to stop this video right there. We've explained all the even ones. If you haven't done the odd ones yet, go back and do all the odd ones. That's what we're doing in class today. If you're stuck and need help, please watch the other video that I already posted. It has all the explanations of the odd ones.